Hi, my name is Gautam, and in this section, I'm going to talk about the algorithms and data structures on binary tree traversal, and also I'm going to talk about the binary search tree, and what are the different techniques in order to insert and delete the tree. So let me talk about the traversal things. Traversal is nothing but like a process to visit all the nodes of a tree and may print their values, because all the nodes are connected like edges and always starts from the root node. This is that is, we cannot randomly access a node in it. There are three ways that we can able to access. As you know, as we discussed in the class, that there are three types of traversals. First is in order, pre-order, and post-order. So generally we traverse the tree to search or locate a given item or key in the tree to print all the values. So let me just explain, in order to make it easier, I will just explain you what is the three types of traversals. So we have pre-order traversal. So in the pre-order traversal, it's a node, left and right. So node represents root, and in order it comes in the middle, so the node should come in the middle. So left, node, and the right. And post order traversal, we have left, right, and node. If you see all the equations, it's how you represent. In the pre-order, the node should come first. In the in-order, the node should come in the middle, and the post-order, the node should come in the ending. So that's how the node represents the root of the tree. So first, let me explain what is in-order traversal. So the nodes always in the middle. So first it goes to the left subtree, and next it goes to the node, and next it goes to the right subtree. So the tree is traversed, and the output will produce sorted key values in ascending order. So we start from A, and following the in order we move to the subtree B, and then so actually see, first we will sort the left subtree, then we'll go to the root, and then we'll go to the right subtree. So the values are first D, B, E, and then it goes to the node, and then left, node, and the right. So this is what the in order. So that's why we can see in the algorithm, recursively traverse the left, then root node, recursively traverse the right subtree. So these are the three steps that you have to do. In the pre-order traversal, what's happening is, first we'll always traverse the node, and then goes to the left, and then goes to the right subtree. So always A, and then goes to B, D, E, then goes to the C, F, G. Node, left subtree, right subtree. So this is called the pre-ordered traversal. And the post-order traversal, we are just going to traverse first left subtree, right subtree, and the root. So this is what the three different types of traversals, and these are the different algorithms. Now let me explain the binary search tree, and what is the binary search tree, and what are its properties. So it's simple, in which all the nodes follows the below mentioned properties. The left subtree should all the left subtree of a node has a key value less than or equals to parent's key, and the right subtree has a key greater than or equals to parent's node key. So if you see this diagram, if you see the number 27, it's 14, 10, and 9. All the values that are there is less than the values of 27. If you see the right, you can see the parent node, it has a root node 35. Yeah, all the values are less than 35 or left child, and all the values greater than 35 on the right child. And for the 14 also, all the value child, whatever the child that you have, the 10 is less than 14, and the 19, all the values on the right child for the 14 node or greater. So basic operations, search, insert, and these are the different types of traversals. So let me just explain you what binary search tree and what are the insertion and deletion process. So in this we have the tree, which we have different types of nodes and all the values, like you can see the root node, and for the root node, for the left values, left subtree values are smaller, and the right subtree values are bigger than the, and then next we'll see the next example. In this example, let's see the second example. So here see, this tree does have the values, all the left subtree values are smaller than 25, but the right subtree, see, 27, 31, these values are greater than 25, but 24 is less than 25. So this is not a binary search tree. So it should be greater than 25. So it can be 20, 26 or anything like that. But it's not a binary search tree, as you see, because binary search tree has a parent key and the left subtree and right subtree. So we have three different types of operations: query in order to search, insert, and delete. Query option can be search, maximum and minimum operation search. And see how we can able to search for k is 12. So how we can able to search is k is so we have to search for the key 12. So we have the root node 10. So is 12 greater than 10? Yeah, yes. So then it goes to the right side. Then 12 greater than 13? No, it goes to the left side. So that's how we need to search for the if you want to go for searching process. If you want to search for 14 also, just you have to compare with the root node. Then if the root node is then if the value that you are comparing is smaller, you have to go to the left side. If the value that you are comparing is greater, then you have to go to the right side, and then recursively see if the values are greater or smaller. Just try to compare and find the values. So that's how the search operation works, and this is a search algorithm. Anyhow, all these algorithms I'll explain in the programming thing whenever I'm doing some kind of programming, whenever I explain some kind of programs using these algorithms. So next we will see insert operation. Suppose I want to insert 26. So how we can able to insert 26 in this one? So now we have to compare. So 30 is a root node, 26 is greater or smaller, so it's smaller, so it goes to the left side. So 17 and 26, so 26 17 is smaller, so it goes to the right side. 24 is smaller, but 26 is greater, so it goes to the right side. So here we can able to insert the 26. This is what the insert operation. And for the delete operation, we have three operations. One has no child. Suppose if you see, I want to delete the node 65, it doesn't have any kind of child or anything like that, so we can directly delete. Now we can just put 55, 57, and that's how the algorithm works. It just we can just simply remove it from the tree. And Z has one child, like if you see 57 I want to remove, and it has one child, so right child we have, so we can directly remove 57, and 65 goes to the up, and then 65 has two childs, left child and right child. So 57 has only one child, so we can directly remove that existing whatever the child, whatever the value that you are getting, you can directly remove that thing, connect the subtree to its parent node. And Z has two child, so this is a somewhat difficult case. So try to see, like 55 and 32 I want to remove, but it has two child, one is a left child 25 and right child 48. For it you have to see the successor. So for 25 it doesn't have any child, but for 48 we have one left child 42, and then 46. So what we have to do, we have to interchange that 42 into this thing. So put 42 here, and then 46 comes on the left side, and 42 goes to the in 32 position. So we have to find its successor. So successor of 32 has 48 as one successor. Successor is nothing but whichever the child node of the existing one has a child node. So 42 is going to get replaced by 32. That's what the delete operation is going to work, and this is what the binary search tree is. And I think so it makes a clear understanding for you in understanding the binary search tree and its operation. And do comment me if you have any kind of questions in the below video, and thank you for watching the video. Have a nice day. Take care.